Hi and welcome to this short tutorial on what is SSH. So let's start from the basics. So SSH is a short form for the secure shell. So it is a protocol for two computers to talk to each other. So it's a way in which one user sitting in one computer can remotely control and access another remote computer and execute commands in that computer. So where did SSH start and why was it created? So it was started originally in Finland by a Finnish computer scientist named Tatu, and it was later revised and bettered by his team with multiple versions. So the most common implementation of SSH, which is used almost everywhere in Linux and Unix and also in other systems, is the version named OpenSSH, which is produced by the OpenBSD kernel developers. So why was SSH created? So it was created by Tatu when he found out that in his university campus, some person had installed a packet sniffer. So a packet sniffer is basically some program which tries to read all the packets of data which is being sent through that network. So the way Telnet used to work, which is the predecessor of SSH, was that it sent all the data through the network unencrypted. So if someone had compromised the network, then all your information being sent was also compromised. So that's why SSH was created, which basically sends the data in an encrypted manner. So SSH packets are basically the building blocks of data. So each packet is something which is sent over the network, and the packet contains the packet length and the length of the padding, which is present after the data, and then the actual data which is sent in each packet, and finally some code which verifies whether the entire packet was sent correctly or something was corrupted during transmission. So usually the entire thing except for the MAC, which is the checksum code, is encrypted, and the payload part, which is the packet data as well as some random padding, is optionally compressed. So here's a detailed schema of the binary packet. So usually there's a 32-bit packet length at the start, and then there's a 1 byte padding length. Then we have the actual payload of each packet, and along with the payload we also have at least 4 bytes of random padding. So these random data are added so that it's even harder for the attacker to decipher the code. So then the entire thing is then encrypted, and along with that a message authentication code or a MAC code is added, and the entire packet is sent. So to reduce the data consumption over the network, the payload part can also be compressed. So it is not compulsory, but it's optional, and both the server and the client cooperate with each other and figure out whether they want to compress it or not. So usually a scheme like zlib or zlib is used to compress, and then but then it is totally required for the packet to be encrypted. So that is non-negotiable, and that is usually done using the AES encryption, which is a symmetric encryption. So what are the uses of SSH? So usually SSH is used to remotely access a server terminal. So you can log into a server which is not present in your house or in your university or in your room, but then somewhere else, and you can access it as if you were sitting in front of it. So that is the primary use case of SSH. You can also use SSH to do port forwarding. You can also use SSH to do SSH tunneling, which is something which we will not cover in this lecture. And you can also use SSH to actually access the entire GUI or the X server. So the X and the X11 system is also something which uses a server client model to show the GUI on the screen. So everything like the mouse and everything which we can see on the screen right now is run on X server, and that also can be run through SSH. So the server can be running in one system, and it can be visible using the X client on another system if it is sent via SSH. So how is SSH secure? So SSH uses usually the AES encryption, which is a symmetric encryption. So how it happens is that there is one key which is known by both the server and the client, and using that key the message is encrypted, and then it's sent over the network. So even if someone has compromised your network and they can see the traffic going from your system to the remote system, they cannot decipher what is being sent. So you can think of it like, let's say all the letters are taken, and then using some mapping which is known only to you and the server, they are translated. So even if they get to see the data, they have no idea what that is. And then because the server also has the key, the secret key, so they can then decrypt the message and then get the actual decrypted data. So that is how symmetric encryption works, and that is what is used for sending the data through SSH. Now let's see how the asymmetric encryption works, so which is used for the public and private key pair. So optionally what you can do is, when you are logging in, so instead of giving passwords, you can use a public-private key pair. So how this works is that it uses two keys. One is a public key and another is a private key. So when someone wants to send you data, what they do is they know your public key. So your public key you tell everyone in the world. So they use your public key to encrypt the data and then send it over the internet. But the way the asymmetric encryption works is that someone cannot unlock the message or decrypt the message using the public key. So although you just need to know the public key to encrypt the message, you cannot decrypt it with just the public key. So only if you have the private key, which only you do and you don't share it with anyone else, can you decrypt the data. So that is the basics of how asymmetric encryption works and how public-private key pair works. So to use SSH in our system, we have two commands which we use directly. One is SSH and another is SSH-keygen. So how it works is SSH uses a client-server model. So there has to be two computers for SSH to work, and one of them will act as the server and another as a client. So the server is where a daemon called the SSH daemon or SSHD is run. So that is the SSH server, and it needs to be enabled and started on the server. So it's not started by default. However, on the client side, we simply use the SSH command to access the server. So we use the SSH client to access the remote server, and that we can invoke anytime we want. So we don't have to enable or start anything in this. SSH keygen is a command which we use just once to create a private and public key pair. So as we saw earlier, the private public key pair is used to authenticate ourselves. So we can use this instead of using passwords to let the server know that we are who we claim to be. So in the server, to check whether the SSH daemon is running or not, what you can do is you can run systemctl status sshd, and given you have SSH and SSHD installed and you're running a system which is using systemd as the init system, then you can run this and it will tell you whether it's active and running or not. So if in case it's stopped or not loaded or just loaded but not running, what you can do is you can run systemctl enable -- now sshd, and this will ask you for your password, and then if you run the status again, you will see it is active and running. So this needs to be enabled in the server. However, for most cases, when you are SSHing into some other server, let's say it be a cloud instance or it be a VM, or it is the actual VM provided by this course, so you don't have to worry about turning on this service because it will be handled by the cloud provider itself. So how the communication works is that first the SSH client, here the user will type SSH and the link of the SSH server, and then the client will send a request to the server. So the connection is initiated by the client. Then the server will send back the server public key, and they will basically, the two client and server will negotiate the parameters of the SSH connection. So whether to do the compression and then what a scheme to use for the encryption. And then finally, when everything has been negotiated, the session is started, and basically the user can send commands into the SSH server. So the user logs in into the operating system. SSH also uses something called channels. So if you, let's say, create one SSH connection from your system to a server, and then you want to create another SSH connection from your system to the same server, so it will not open two separate connections, but it will use one single channel and it will do the multiplexing on its own. So SSH handles the channel multiplexing. Alright, so now let's see how we can log in into the VM without using a passwords. So we are not allowed to log in into the system commands VM using passwords. So what we have to do is we have to first create the public and private key pair using SSH keygen, and then we have to copy the public key to the server. So first open your local system. So if you're using Windows, you can use PowerShell, or if you're using Linux in your local system as well, you can open any terminal and type this command SSH-keygen. So this will create a public and private key pair in your local system. So you can give -t and RSA to specify what type of key you want. So usually it will create RSA, but if you're using a updated version of this command, it will then create a ED key. So if you don't mention this, it will try to create a ED25519 key. But if you want to, let's say, create an RSA key, we can give -t RSA. So this will ask you where you want to store the key. So by default, it's stored in your own home directory inside the .ssh folder, and it is given a name ID_RSA. So you can give a different name or a different path to this, but by default, this is the path which will be used. So you can simply press enter, and then it will ask you for the passphrase. So this is optional. You can give a passphrase to this key so that the key is encrypted, and whenever you want to use this key, you will actually have to give this passphrase again. But for simplicity, let's skip this step and just press enter here. So we'll again press enter, and our private and public key pair is now created, and it's saved in the /home/your username .ssh, and then ID_RSA is your private key, and ID_RSA.pub is your public key. So this public key is something which you share to others and which you will upload to the server. So the first step is to first see now that whether the key is created or not. So let us cat out the key and see if it's created. So we'll go to the SSH folder and cat out the id_rsa.pub, and as you can see, the public key is now created. So I can simply copy this key from here by selecting it and pressing Ctrl+Shift+C if you're in a Linux terminal, or if you're on Windows PowerShell, you can right click and copy. Another way you can copy if you're on Linux is you can use the xclip or the xcell command. So this will put it into your clipboard. Then we open this website, which is se2001.ds.study.iitm.ac.in, and here we have to log in with our IITM student email ID. So just select your student email ID, and then you will be redirected to this page where you will be asked to create the SSH key. So these are the exact steps which we took to create this SSH key. So once it's created, you can then copy the key, public key, from the location, and then you have to paste it in this form. So simply paste it from your clipboard, and the key should usually start with SSH-RSA or SSH-ED, and the username will be autofill. So you have to simply press submit, and the public key is now uploaded into the server. So now you can log into the server using the commands given here. So SSH your roll number at se2001.ds.study.iitm.ac.in. So let's see if we can log into the server. So we copy this command and we open a terminal again, and we simply have to paste this here. So the first time you are doing this, it will also ask you if you want to save this and do you trust this domain. So you have to simply type yes and press enter, and after that it will automatically log you in. So as you can see, now we are logged into the VM, and you can verify this by echoing the host name. So the host name is SE2001. So on your system, your host name will be whatever is your device's name, but once you have SSH'd into it, you are now inside the VM and you will get the SE2001 as the host name. You can also see who is the account holder in which you're logged in, so that will be your register number. So that's all you need to do to log into the VM. So the public key which we created in our local system is now stored in this user's home directory inside the .ssh folder. So even in the remote server, we will have a .ssh folder, and in there we'll have a file called authorized keys. So in that authorized keys, we will have the SSH public key which we uploaded. So wherever you want to SSH into, just make sure that your public key of the local system is pasted inside the authorized key of the remote system. And if there are multiple keys, you can put them on separate lines. So this is done automatically by this website for us. So now that we are logged in, let us explore how the VM is structured. So you can see in our home, we have one README file. And in this README file are all the instructions that you need to follow. So we can simply do cat readme, or if you want, you can do cat readme, and it will give you a paginated view of the README file. And you can read all these instructions to understand exactly what you need to do. So now let's see how to use SCP and SFTP. So as we saw, SSH lets us to log into the server and then execute any commands. But sometimes we only want to copy some file from the local system to the remote, or from the remote to the local system. So that is accomplished using the SCP command, which stands for secure copy. So we can see the man page, and we see that this is secure file copy using the SSH protocol. So the syntax of SCP is similar to how CP works. So this means copy the file A as file B. Similarly, we can use SCP to copy a file A to file B, but if you want to copy to or from a remote location, we will have to give the username and the link to that place. So let's say I want to now create a file here. So I will create a file named hello from my own system and store it as a hello.txt. So if I cat the hello.txt, you can see that we have the text hello from my system, and this is stored in my system. So if you do whoam, you will see your own username, or if you do hostname, you will see your own system's name. So now let's SSH into our remote system just to make sure that this file does not exist there. So we can simply do SSH, and we see that we don't have any hello file in our remote system. So let us now try to copy this file from our local system into our remote system. So we don't need to be inside the remote to do that. So I'll log out. And now what we need to do is we need to use the SCP command. So we do scp hello.txt to copy the hello.txt into our remote server. So the user in which I want to copy is 21f100 6567, that is my roll number, and then at the URL or the IP address of the system. So we have the URL as se2001.ds.study.iitm.ac.in, and after this we will put a colon, which means that now the path is going to start. So anything before the colon is how to identify the system, and after that is the path. So because we are logging in as a user, we cannot simply copy this to the root or somewhere else. So this will be stored inside the home directory of this user. So let's say I name this hello.txt as well, and I press enter. So because we have configured the private key and public key, and we have uploaded the public key in the website, so this will automatically, without any passwords, log in and copy the file, and it will again log out. So as you can see, we are now again back into our local system. So let us now SSH into the remote system to verify whether the copying was successful or not. So you can see here, if I do ls, we now have two files earlier which did not exist. So if now I do cat hello.txt, we can see that that text is now copied into this remote system. Similar to SCP, we also have SFTP, which is a secure file transfer protocol. So usually we have the FTP command to do file transfer protocol. So just like HTTP is a hybrid text transfer protocol, we can use FTP to create a FTP server so that we can transfer files quickly. But FTP is non-encrypted. So if the network is compromised, anyone who is sniffing your packets can easily see what file you are transferring. So SFTP is simply a replacement for FTP, which uses the open SSH way of transferring files. So it encrypts it and then it runs a FTP server. So we can use SFTP instead of FTP, and we can transfer files from one server to the other using the FTP protocol. So the protocol remains same, just the way of transferring is now encrypted. So that's all we have to cover for this short tutorial. So these are a few resources you can go over to know how SSH works and what are the basic differences between SSH and Telnet, and why SSH was created to replace Telnet. You can also see the architecture of SSH and what are the packet details of SSH packets. Thank you.